Okay, so we're going to start with a short video which gives a lot of overview on what Mattereum does and what we're doing, much faster than I could summarize in the talk. So we'll start with the video, and then we'll go into the slides, and I'll give some explanations in more detail.
What would business on the blockchain look like? Smart contracts open up a vast new space for automation, not just for money and digital assets, but also physical assets, intellectual property, and services. The potential market is huge. But how do you connect code with physical assets? What happens when there's a bug or when real-world circumstances change in ways we didn't expect? To put business on the blockchain, we need the right legal and technical foundations to support it. This is what Mattereum provides with its platform for decentralized commercial law. By combining smart contract code with the necessary legal terms, business can be automated while ensuring the correct interpretation of everyone's obligations when something goes wrong. Take a container of goods sailing from China to Europe. A smart contract records its movement from factory to shipping agent to customs officer to warehouse, automatically generating relevant documents and paying fees and taxes. But if something goes wrong along the way, the shipment is delayed or the goods are not what was expected, that's where you'll be glad the contract was built on Mattereum. With decentralized dispute resolution, claims big and small can be resolved fairly and efficiently by independent, technically competent arbitrators. And national courts can enforce their decisions wherever the businesses and assets are located, in more than 150 countries. With Mattereum, commercial agreements can be made with confidence, combining the efficiency of automated smart contracts with the reliability of international arbitration. That's business on the blockchain.
Great, thank you. Now, we've heard a lot this morning about dispute resolution and the necessity for dispute resolution to be able to make blockchains work properly. So what Mattereum provides is one approach to dispute resolution for commercial contract. It's a very, very straight down the line legal approach. There is minimal dependence on technology. It's relatively technology independent. The processes are exactly the basic processes that Ian Grigg designed 20 years ago, and we're sticking fairly faithfully to Ian's model because he got it right the first time. What I want to talk about is how these models evolve over time and how we can expect the future of global trade to be transformed by blockchain and the arbitration structures that hang off blockchain. So this is a kind of historic perspective, and I'll get into some of the thorny issues around identity and credentialing as we get towards the end of the talk. So we've seen a lot today about the history, so I'm not going to dwell here for too long, apart from to really focus on how long the gap is between these things being initially created and the full global transformation that emerges. So public key encryption itself is now over 40 years old, and blockchain still is perhaps 1% of humans have a reasonable awareness of it. So 40 years to 1% penetration is a really long, slow process. This is the kind of dignified arc of history. And it doesn't matter how much we want that to go faster unless you're willing to spend billions of dollars of investor money advertising new ideas and trying to create social change, which is basically the pets.com phase of the internet bubble in the late 1990s. Really, things take their own time. It takes a very long time before institutions change their mind because individuals, generally speaking, once they're promoted to positions of seniority, do not wish to make mistakes. And as a result, the rate of technological change slows down when you begin to get into what we kind of casually term the real world, by which we really mean institutional decision-making by actors who've got 20 years of seniority and pension to protect. There's an inevitable slowdown. So today, the big kind of technological horizon, the frontier, is ZK snarks. And ZK snarks are pure moon math. They're extraordinarily powerful magic. In that they allow you to do transactions on a blockchain which can be verified as being correct without revealing the details of the transaction. Everybody knows that the transaction was created in a way which is not fraudulent. They know the transaction is legitimate. You just can't see what was paid to who. And those kind of systems are enormously powerful. They're headed for 20 years old, right? As we begin to see, the next 10 years, it's logical to expect those technologies to become a critical part of the blockchain story. It will change what is possible in ways which are currently seen in things like Zcash, or indeed Ethereum's support for Zk snarks, but it's just the very beginning of that revolutionary change. And this sort of slow, ponderous timescale is very different from the sort of standard narrative around technology, which is that it's all white heat and instant transformation. It isn't white heat and instant transformation. It's a slow, ponderous, grinding process of social change, and it doesn't go any faster than any other kind of social change goes. We're in a position where society will move at its own pace, and the technology will be absorbed as fast as people are ready for, but no faster. So when we start talking about the transformation of global trade, it's worth understanding that we don't think of this as being an instant process. We're not predicting that 5 years from now, 100% of everything will get done on blockchains. It's more a case of, over the next 10 to 20 years, we expect a revolution which is as slow and as heavy as the containerization revolution was from the 50s through to the 80s. It's a similar kind of structural change. Oh, wait. There we are. Now, the second part of the sort of blockchain meta-narrative that I want to challenge is the idea that there is a certainty that we will win. And this is a very, very, very common opinion in the blockchain space. There's a lot of sense of historical inevitability. If you talk to people that have been around the Bitcoin scene for 5 years, they'll tell you Bitcoin will reach $100,000 this year. It will become the world's reserve currency. Bitcoin derivatives will turn out to be what people use for trade. It will go 1 million transactions a second, and the entire universe will change. And I'm a veteran of several failed revolutions. The feeling of historical inevitability is, generally speaking, something that young people feel. And part of becoming middle-aged is you see a few revolutions that you were sure were going to work fail, and then you begin to realize that the world basically does its own damn thing regardless of what you want. So the feeling right now is that cryptography is inevitably going to be a technology which empowers individuals. And it empowers individuals relative to corporations, relative to the state. That it shifts the balance of power towards the individual in a way which in some way neatly compensates for the concentration of power in the hands of organizations like Facebook or Google. And this is the kind of dominant narrative. Same thing for decentralization of networks. The feeling is that you could create distributed computing systems. The distributed computing systems will spread out across the world, and everybody's computers will connect together, and you can use this instead of cloud. Lots of things like Filecoin kind of predict that as a historical inevitability. Of course, this is the way that we will go. And that's not an unlikely evolution, because Google or Facebook are only spending a few dollars per person per year on compute power. They're not spending heavily, whereas individuals are spending maybe $1,000 a year on computers, including their phones. There's a much heavier investment from the people than from the cloud in terms of buying computing power. But whether you can organize all of that into a kind of fluid compute surface that spans the entire world is an open question. Whether or not we take this path or whether we take another path, nobody really knows. So we're in a position where everything is to play for. If we hit the critical windows, if we find the correct moments of transformation, we can get an outcome in which individuals are empowered and in which the world works better for the individual. If we miss those windows, we get different outcomes, and you could see the creation of enormous new global compute platforms that are accountable to nobody and that make Facebook and Google look relatively mild by comparison. We just don't know which way this goes, and it's at conferences like this one where the conversations which will happen, which will drive us towards one or the other of those potential futures. Now I want to talk about the macro scale moment. We're in a position really since the 1960s where the speed of light has become the dominant frontier in the way that our civilization operates. Globalization, when we were dealing largely with container ships, was bound by the speed of a ship, and the speed of a ship is a relatively uncomplicated thing, right? They go as fast as they go. There's not much you can do to accelerate it other than add more energy. As we began to see the revolution triggered by undersea cables and then satellite communications, you began to see global trade working at the speed of the speed of electronic communications rather than the speed of things like post. Even telephones began to accelerate global trade. But since the space race, you've really seen this become the dominant global driver. There are four big systems, roughly a decade apart, which kind of are the instantiations of this technological shift into a genuinely synchronized global society. The first is the global positioning systems. You use this every day to navigate, but the global positioning systems are dependent on the delay in the speed of light. Light takes roughly 1/7 of a second to go all the way around the world, 130 milliseconds. And by measuring the distance between us and a satellite by the delay in the length of time it takes the signal to propagate, we can find our location. So if I'm at a point on the Earth and I'm 150 milliseconds from this satellite and 200 milliseconds from this satellite and 158 milliseconds from this satellite, I could figure out where I am to within a few meters. And that's entirely dependent on how accurate the clock is on my phone and how far away the satellites are and the speed of light. And that's our navigation system. We depend on the speed of light for our navigation systems. Similarly, something like 50% of all the world's commodities are traded with high-frequency trading. High-frequency trading, you take a single enormous computer system, you locate it at a central location, and these systems are processing on the order of 10 million transactions a second. They're extremely fast. 1/7 of a second delay is over 1 million transactions processed, which is why you don't do high-frequency trading from Australia to an exchange in New Jersey. Right? The length of that delay makes it impossible to compete in the global economy unless your computers are packed into the exchanges where the high-frequency trading systems run. And remember, this is 50% of global trade. They're literally measuring the cables to make sure they're exactly the same length in the data centers, because if the cable is 6 inches shorter, you get a nanosecond of advantage, you get to trade a little bit faster, and as a result, you're continually at financial advantage. And the figure is bandied around that it's $600 million a year for every nanosecond you get closer to being the first, every millisecond you get closer to an exchange. Not nanosecond, millisecond. So those kind of structures drive the global economy right now, but they're incompatible with fair globalization because that model automatically favors the country that hosts the exchange, and as a result, you wind up with not just a geographical center, but also a jurisdictional center. If the exchange is in Connecticut, in America, all of the transactions that happen on the exchange will happen under American law. And in the long run, in an age of increasing global trade and increasing decentralization, in a condition where the kind of equilibrium that formed in the world after World War II is beginning to break down, it's very hard to imagine that the future of trade will favor one jurisdiction over another jurisdiction when we want to transact. It's very, very unlikely that we're going to wind up with a single global architecture located in a single nation state, because at the end of the day, even the largest nation states are a small minority of the world's population and a small minority of the world's trade. It doesn't matter who you are, most of the people live somewhere else, and as a result, we're going to find a compromise which works for everybody globally, rather than a single system that drives and dominates the entire world. The fact that we've got a 50% concentration of trade in high-frequency trading systems right now, that is not a sustainable equilibria if we're going to wind up with a global trade system that works equally well for everybody. The next system I want to discuss is Google Spanner. So Spanner is the system that allows you to, for example, edit documents with many people editing the same document without people continually overwriting each other's work. And Google Spanner operates at enormous expense by putting atomic clocks inside of every Google data center and then very carefully synchronizing all of the machines by doing things like measuring the latency between all of the data centers on a continual basis. And Spanner basically works a little bit like a blockchain in that it has a sort of block time, a delay built into every transaction. In this case, it's 7 milliseconds. So 7 milliseconds is just enough time that the spanner network can say for sure that the transaction didn't happen before that 7 millisecond window has elapsed. And it provides a way of getting all of the transactions in the Google system, including things like the advertising systems, within this kind of 7 millisecond time window. And that's how they manage the fact that you have 130 millisecond speed of light delay, which by the time you're working on the internet is more like half a second, 500 milliseconds. So they're beginning to build a kind of high resolution timing system that is roughly 50 times more accurate than just waiting for the messages to relay on the network. But that's probably as good as you could do inside of that paradigm. And if you want access to the spanner system, you're now dependent, instead of on a single nation state, you're now dependent on a single company. So you can get a fairer global system in which you've got some kind of global synchronization to occur, but you could get within this 7 millisecond window only at the expense of having all your transactions routed through a single company. And in the same way that routing all your transactions through a single jurisdiction isn't a good idea, routing all of your transactions through a single company is, if anything, a worse idea, because you have all of the restrictions from that company's jurisdiction, plus whatever restrictions that company chooses to impose. So that set of structures all work relatively well for the things that we're currently doing, but they don't provide us with a way forward if we want to conduct global trade on a truly equitable basis. We all know that there is a need for a new generation of global trade agreements. Whether those agreements are de facto agreements involving technology or de jure agreements where we come together and form new international treaties, we don't know. The large international platform treaties like the Trans-Pacific Partnership, NAFTA, the UN, the European Union, all of these arrangements are under an enormous amount of strain because the political environment that created that model of globalization no longer exists. We're in a world which no longer seems to have the will to create these large world-spanning agreements where 50 or 100 governments come to the same conclusion and agree that they will modify their laws to fit. Instead, we're in a position where global trade is becoming increasingly a matter of technological synchronization between trading entities around, for example, things like container ports. So the possibility is that we're moving from an age in which trade is harmonized through law to an area where trade is harmonized through technology. And this is really what I want to communicate today. The blockchain, in its future incarnations, as it evolves and becomes more sophisticated, will potentially take a lot of the strain out of global trade and fulfill the vision that was originally instantiated in organizations like the World Trade Organization, or for that matter, the United Nations. The possibility is that we can provide a synchronized global trading environment without having to go through the enormously long political negotiations to harmonize everything at a political level. If the technical level is sufficiently sophisticated, you may not need to go through the political process. And a good example of this is telephony. You know, the entire world operates really, really very smoothly on a standard like phone numbers. IETF provides things like the domain name system, and these are technical infrastructures which support global trade without having required enormous treaty negotiations to get these things working. There are some international treaties under those, but it's not the endless process that you get, for example, in the typical trade treaty. I want to say one thing about the CAP theorem. The CAP theorem is very, very, very important to understand if you're interested in blockchain. Not very many people have read the paper or read dialogues on the paper. It's really worth going back to understand because it conveys the absolute certainty that a blockchain-like system has to exist in order to be able to carry out this global synchronization. Without it, it just doesn't work. But very few people in the blockchain space have gone back to read that paper, and without it, it's very hard to understand what it is that happens at a fundamental level. So I really want to recommend getting some familiarity with CAP, if only because it gives you the sense that what you're doing is fundamentally correct, rather than a technological happenstance. Now, I want to talk a little bit about the unsolved problems. Right now, if you're in any real contact with the blockchain space, you're used to people sending you long strings of numbers as addresses. Send your payment to this. And those payment instructions are typically being sent over unencrypted email or internet chat programs like Telegram or Signal, or they're being sent around as screenshots. Once in a while, somebody will call somebody on a telephone to verify the address is correct, but for the most part, these things are just being sent by email. And as a result, there's a ton of fraud. There are viruses which will sit on a computer and will rewrite the address when you paste it from one place to another. People are hacking each other's websites and putting up fake addresses for ICOs. There's tons and tons and tons of attacking the addressing that we're using to send value around the world. And those kind of attacks are happening because we've got massive use of public keys, but we haven't built any public key infrastructure to provide context around a key. So we have one of these strings, it identifies a payment endpoint. It doesn't tell you who owns the payment endpoint, it doesn't tell you what you're paying for, it doesn't tell you what the policies are. There's no objective way of locking a set of policies or a set of contracts to an address. And until we solve that problem, it's going to be very difficult to use blockchains for real trade because you can't just send a sort of payment address which is non-repudiatable. When the payment is made, there's no way of getting the money back. And if you're going to do that kind of stuff, you can't handle these things in the same way that you handle, for example, bank account numbers. If you have a bank account number and a payment goes wrong, in all probability, the bank account transaction, the bank can be contacted and the transaction can be reversed and you could get your money back. So we could be slightly casual around bank account numbers. You could accept it in an email. Maybe you could accept it as an automated transmission of an invoice. But you're not in a position where once the money is gone, it's gone and there's no way to get it back. What we haven't done is built the necessary security arrangements around blockchain addresses in order to be able to verify what the address is before funds are transmitted. Now, the conceptual work to make that possible was done 20 years ago. That was when HTTPS was set up in the system of certificate authorities. There are also models like the GPG Web of Trust, which also date from the same historical period. 30-year lag is what we expect. Those technologies are 20-something years old. So that slow progression, Xanadu takes 3 decades to become the web. Capability-based operating systems are still just kind of bubbling under the surface. You see the beginnings of that material breaking through in things like the application-level permissions in Android. I'm expecting the next revolution in blockchain to be the final rollout of PKI that works, a way of attaching metadata to keys that will allow you to be sure who you're paying and what you're paying for. I would like to imagine that that will be built on an old system called SPKI, updated as SDSI, because I think the fundamental analysis that was done in those systems about what the meaning is of a set of secret keys, how the public keys are bound to each other, how we identify individuals in an identity sense. I think all of those systems were basically figured out 20 years ago, but the core ideas have largely dropped out of currency. So I want to finish by talking a little bit about arbitration and dispute resolution. What Mattereum does is we work with companies that want to do real trade on the blockchain. And most real trade is for what we term fiat assets. So a fiat asset is an asset which is created by a government. For example, all copyright is created by law. Copyright doesn't really exist in nature. Copyright is a form of property that's created by a government. A domain name is a form of property that's created by a set of international treaties. Physical land is owned inside of complex legal structures, and when we transfer physical land, we don't pick the land up and send it to somebody. What we do is we update a government register of who is allowed to do what with the land. It's a set of legal rights which are updated. So this is the general class of things that we call fiat property. So the link between fiat property and the digital world is very, very weak. There are very few land registries which have an API that will allow you to directly write to the land registry from a blockchain. I think the number might be 0, maybe will be 1 in a couple of years, but it's a very, very, very large gap. And the world that we all envisage is a world in which we have a smart contract. You send value to the smart contract updates the current owner of an asset, and then the government magically recognizes that the asset has changed ownership, and as a result, your trade has been successful. So building the necessary legal infrastructure to make that take place is a multi-year process. Right? We can start with easy cases like copyright or patent license, simple forms of property like what they call chattel property. For these things, building a set of contracts and an execution environment for those contracts which will allow immediate transfer is relatively simple. And we're working with about 6 companies on making those kind of transfers possible. As we progress down the path, we will see disputes, we will see situations in which a transfer is effected, but it doesn't go through. And for that, we have a dispute resolution mechanism, as you saw discussed in the talk, on exactly the foundations that Ian Grigg and Joseph Poon discussed. So we're really just taking the ambient awareness that dispute resolution is necessary and that we need legal machinery to effect property transfers, and we're building those systems out in a way which is independent of blockchain, any specific blockchain technology and usable all around the world. We're starting with Ethereum because Ethereum is where I started out. I was the project manager for the Ethereum release and did a lot of the early communications work. So we're working there first because that's where our community is. But we're available to work on anything for anybody because we can work for corporates or for startups. We can work on Ethereum or another blockchain, and we can work with physical property or intellectual property. So that's the Mattereum story, and thank you very much.
Thank you very much.